So today we're going to remind ourselves how to multiply and divide with fractions. When you multiply normal number fractions, for example, 2/3 times 4/5, what do I do? Yes, you.
Okay, you have to find a common denominator of the...
Do I need a common denominator for multiplication? No, I don't, which is awesome because it's a lot of effort finding common denominators. What can I do instead? Do I need to cross multiply? No.
Times numerator and denominator.
Just times the numerators together?
Yeah.
Times denominators together. So super easy. So 2 times 4, 3 times 5. Okay, so multiplication is probably the easiest operation for fractions. You just times the tops, times the bottoms, and you're done. All right, it's the same for algebra. So if I had, for example, a over 3 times 2b over 4x. What do you think the answer is going to be? Start with the numerators, I multiply them, what do I get?
2ab
2ab, well done.
over 12x.
12x, beautiful. So when you are multiplying fractions, you just multiply the tops and multiply the bottoms. The rule doesn't change just because there's letters there. Now, when we got trickier questions for multiplication, we would sometimes simplify before we did the question. Let's look at how that works with numbers. So for example, if I had 21 on, say, 16 times 8 over 14. Okay, yep. So before I start multiplying, I don't really know my 16 and 14 times tables. Right? We're pretending I don't have a calculator at the moment. I don't want to do 16 times 14 and I don't want to do 21 times 8. That's too hard. What can I do to make this question easier?
You can try simplifying the numbers.
Yep, what could I do? Can you see something here that could be simplified? Yep.
The 8 and the 16.
The 8 and the 16. Well done. So anything on the numerator, as long as it's multiplication, can cancel with things on the denominator. So 8 on 16 is better known as what? A half. Okay, so 8 on 16 was simplified to 1 over 2. Is everyone happy with that? So instead of that 8 and that 16 being there, I'm going to change that to 1 on 2. Are we happy with that? What else can we see?
But aren't they like in different...
They are in different fractions, you're correct. I'm only allowed to do this if it's a multiplication, and it must be something on the numerator with something on the denominator. If that was a plus, I couldn't do this. This is the only reason I can do this is because I know that all the tops are going to join together in the next line. And so I can combine them. Before combining them, I can cancel. Because it's much easier to multiply by 1 than it is by 8. Anything else?
The 21 and 14 are divisible by 7.
They're divisible by 7. So what does that simplify to? 3 over 2. So this becomes 3 over 2. Now, I'm pretty sure that 3 times 1 and 2 times 2 is much easier than 21 times 8 and 16 times 14. So because of that simplification, it's really easy to get the answer. It's just going to be 3 over 4. Alright, so that's a nice little answer. The same thing happens with algebra. So I am going to try and look for things that cancel before I do the question. So for example, if I had 20x squared over 9y times 6y cubed over 10xz. Okay, that looks pretty disgusting. What can we cancel? Anyone see anything that can cancel?
You can cancel 9y and 6y cubed.
Yeah, so what would will happen there when I cancel that? The 9 and the 6. Let's just look at the numbers to start off with.
3 and 2.
That's correct. So that's going to become 2. That's going to become a 3. What about the y's? What's going to happen there? I'm going to be careful with that because one's a y and one's a y cubed. So it doesn't completely cancel, does it?
Leave them as they are.
We don't want to leave them. We want to cancel them a little bit. Got to remember what y cubed is.
3 y's, so you can cancel one of them, so it'll just be 3 and y squared.
Oh, well done. So this y cubed means there's 3 y's, okay? Only one of them is going to cancel. So this y is going to completely cancel. Over here, instead of having 3 y's, I've got 2 of them. Does everyone understand that? Does that make sense? So instead of being y times y times y, there's now 1 gone and it's just y times y. Cool. All right, so we've done that one. Anything else? Yep.
We can do the 10x.
Yep, so we can go, we're going to go this way as well. 20 and 10, that would just be 2 on 1 actually. So 2's on the top, 1's on the bottom. What about the x's? So this is an x squared, this is an xz. What are they going to end up being?
Just 2x and then 1z.
That's correct. So down here, so up here, this x squared, there's not going to be 2 of them anymore, there's only going to be 1. So it's not x squared, it's just x. Over here, instead of xz, the x is completely gone, and it's just a z. Alright, so it's looking very messy there. Hopefully we can see where it's all fallen together. So here I've got a 2x and a 2y squared. When I multiply that all out, what do I get? Yep.
Isn't it 4xy squared?
4xy squared. Well done. What about on the denominator? What have I got left? Yep.
3z?
3, and all I had over there was a z. And that's the answer. Alright, we're going to stop the video now, and you're going to have the time to try a couple of those.